In this video, I'll be helping you to diagnose a fault in a frost-free freezer or fridge freezer. Now, generally speaking, most faults in fridges and freezers are very simple to diagnose and actually just involve replacing the faulty parts such as the door seal or the lamp. However, because of how they work, frost-free appliances tend to be a little bit more complicated. Now, they do actually develop frost, but you can't see it because it's concealed behind a cover in the back. Now, to give you a better idea of what's going on, I'm going to remove the shelves and the ice box as well as the back cover so we can see the components inside. Here in the back we have an evaporator. Now this is essentially a radiator which is cooled by liquefied gas being pumped through it from a compressor. This fan up at the top draws air into the appliance and it then blows air across the evaporator. Now, because the evaporator is cool, it cools the air temperature and that air is then distributed around the cavity by the fan, freezing anything that's in there. Now, on this particular model, some of that air is also ducted into the fridge compartment and the flow of that cool air is controlled by a motorized flap and it goes in through this duct up at the top here. It then travels down through the fridge and returns through this duct at the bottom. Now, when you open the freezer door, the cool air inside falls out and it's replaced by the warm, moist air in the room. The moisture from the air settles on the cool evaporator, where it then cools so much that it turns to frost. Over time, a buildup of that frost is going to affect the airflow. So for that reason, there is an element fitted underneath the evaporator which turns on round about every 16 hours of the motor running and for a little while heats all of that frost up so that it can melt and drain away through the hole in the bottom and out the back. Now, the most common fault that occurs in a frost-free appliance is the build-up of ice on the evaporator. If ice builds up, then obviously it's going to affect the airflow and that means that the temperature is never going to get low enough. Now, causes of that could be a faulty heater, a faulty sensor or fuse, or a fault with the control board or timer. Now, to test the heater, you'll need to trace its connections to the plug. In this particular model, the wire goes from the heater up the side of the evaporator and behind the fan to a plug in the ceiling of the freezer. You'll need to disconnect the heater from the plug and test its resistance with a multimeter, and you're looking for a reading of somewhere between 200 and 300 ohms. So obviously any reading outside of that would indicate the presence of a fault and you'll need to replace the heater. You may also have developed a fault in the sensor or the fuse which is located near to the heater. Now, a working sensor or fuse should get a reading of a short circuit of less than a couple of ohms, and again, any reading that's different to that would indicate the presence of a fault. There may also be sensors around the evaporator, and for that you should be getting a reading of anywhere between 2,000 and 40,000 ohms. Any reading outside of that would show that there is a fault there. Once you've checked all of those areas, then the most likely source of the fault is the control board or timer, and you'll need to get those replaced.